Hi, my name is Eric Johnson. I'm a Senior Developer Advocate for Serverless at AWS. And today I'm excited to talk to you about HTTP APIs, a faster, lower cost, better way to build APIs. So a little bit more about who I am. On Twitter, I can be found at EDJGeek, where I talk a lot about serverless and my family and drums and pizza and Dr. Pepper and different things like that, but primarily serverless. If you need help, this is a great way to get a hold of me. I'm glad to try to help or find someone who can. Again, I'm a Senior Developer Advocate for Serverless. I've been a software developer and a software architect for many years, since 1995. I am old guy, so. All right, so let's get started. For our agenda today, we're going to be talking about a quick history of API, gateway, and APIs in general. What does it mean to be faster, lower cost, and better? What the HTTP API features are and picking the right API gateway for you, and the future of API gateway as we go forward. So let's jump into a history. What we did and what we're doing. So when you think about APIs, it's first of all important to understand what is it. So in building applications, an API simplifies programming by abstracting the underlying implementation and only exposing objects or action the developer needs. So really, it allows communication between your client and your API or other services in your API or even within the application itself. It helps to just provide what's needed for the communication and nothing else. So if you look at this architecture, we have a client who makes a request to the API. The API will then interact with backend services like compute or storage, and then it will respond to the client. Now in the backend services, you're going to have your database, which is going to maybe do data persistence. You're going to have your compute, which does business logic, things like that. But with API gateway services, you can roll a lot of your logic out to API gateway through routing, authentication, throttling, cache, data validation, and other things can be taken into the API service rather than handling them in your application, which helps to make a consistent interface for this and bring it all to one place. To answer the API call, in 2015, we released API Gateway, which is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. We released it in 2015, but we've been working on it since then to meet customers where they are, to help them take the heavy lifting of things like CORS management, or Swagger import, or binary data support, custom error responses, regional endpoints, different things like that. We've constantly been working to make API Gateway better. In fact, in 2018, we released the WebSocket API to allow developers to use WebSockets with API Gateway. In 2019, just last year on December 4th, at reInvent, we released HTTP APIs in beta. And I'm excited to announce that on March 12th of this year, HTTP APIs have gone generally available. So, as I've explained here, we've been working with API gateways for over 4 years now. In fact, almost 5 years. And we've done a lot of work on this. So we sat down last year and we decided, how can we make API Gateway even better for our customers? How can we meet what the customers are asking for and really, reduce cost and all the things that they're asking for? So what we did is we embraced the lessons learned from building the REST and WebSocket APIs. What worked, what didn't, what could be better, what was great, where are the paper cuts, different things like that. We prototyped multiple languages, new technologies, and patterns that weren't available when we started building API Gateway. And of course, we evaluated customer feedback. If you know anything about AWS, customer feedback, customer needs drives a huge part of our roadmap. What do our customers need? What makes their life better? So the result is we built HTTP APIs from the ground up to be faster, lower cost, and better. So let's jump into that and see what that means. Well, faster, we all have the need for speed, right? As a developer, and I've been a developer for a long time, clients constantly want, hey, we want it faster. We want the application faster. We should get a result. In today's age, if I don't get a response immediately on a website, I assume it's broken. I'm going to move on. And that's the culture we live in. So as developers, we're challenged to do things faster. So we built HTTP API with that in mind. And the result is 60% lower latency at P99. Now I say that and some of you may be saying, what does that even mean? Well, let me explain the impact and what this means. So when you think about an architecture or a request, you have to know that every service that touches the request introduces a certain amount of latency. Now I'm doing a serverless example here to show Amazon API Gateway and AWS Lambda. Each of these will add a small bit of latency, but this is with any architecture that you may use. It could be, containers. It could be, a box in your mom's closet. Any of those are going to add latency to the request. With HTTP API, we have been able to reduce that to where 99% of requests, so that's the P99, will have less than 10 milliseconds of latency added from API gateway services. And that's not just going in and then coming out, that's the combined latency added overall. So what that means is the combined request and response will be less than 10 milliseconds of latency added from API gateway, and this is across the API gateway service as a whole. So we're really excited to say that it is faster. Lower cost. Well, frugality. Frugality is a big thing at AWS. We believe in being efficient, we believe in keeping costs low, and we believe in passing those cost savings on to our customers. So let's look at the pricing for API gateways and compare them. Now these prices are in US East 1. And when you look at the REST API prices, you can see that the first 333 million requests are $3.50 per million. And it goes all the way up to 20 billion where it drops down to $1.51 per million requests. However, with HTTP APIs, the first 300 million are $1 per million, and anything over 300 million is 90 cents per million. So it's obviously a lot less expensive. Let's look at that in real world examples. You can see here I have some examples where in the first one we have 100 million requests per month. And that would cost $350 on REST API and $100 on HTTP API. And you can see where at 500 million, you can start to really see the difference between those, and then 1 billion requests. The resulting answer is HTTP APIs is up to 71% less expensive. So faster and lower cost. So let's talk about better. And how do you quantify better? What does better mean? Well, let me explain it. First of all, it's faster and lower cost. And that's just reality. If you can do the same processing, if you can handle the same type of services in a faster, less latency manner with less money coming out of your pocket, that's better. But that's not where we stop. We also make it easier to use. Let me show you what I mean. We have a simpler UI now. If you look at our UI, you can see here where you've got the different settings that you want to make with routes, authorization, integration, and so on. And these are easy to get to and they're easy to understand. Let's go into one of these so you can kind of see what I'm talking about. So let's look at the CORS settings. Now, first of all, if you're not familiar with CORS, this is cross-origin resource sharing. And what that means is if I have a client that's sitting in a domain, something like mydomain.com, and you have a server sitting on a domain, something like yourdomain.com. Well, right off the bat, my client can't talk to your server. But that's part of the practices that we do a lot is we call services that are not part of our domain. And so that's where CORS comes into play. Now, when I'm speaking publicly, a lot of times I'll say, how many of you, and I'll be in a room of hundreds of people, how many of you love CORS? And I'm telling you right now, nobody raises their hand. CORS is not an easy thing to do. However, CORS is a way of life, and it's something that we need to deal with. A lot of times what developers will do is, because the complexity of CORS is they will just simply open this security layer wide up. For the access control, allow origin, they'll put a star in. For the allow headers, they'll put a star in. So what that means is their server will allow any service to talk to them. They depend on their own security to handle, maybe any intruders. But CORS is a layer of security, so we should be taking advantage of that. And so what we've done is by simplifying the CORS integration, the CORS configuration, We believe that developers can approach this and take advantage of cores by setting these up and using them properly. So don't forget your cores. Set it up, use it, let it be a layer of security. Anytime you have a layer of security available to you, use it. All right, so let's jump into the HTTP API's features. And the first thing we're going to talk about is what was released in beta. Quick list here. In December, we released integrations with AWS Lambda functions and HTTP URLs. So you're able to, again, integrate with any Lambda functions or any HTTP URL that you can point at. We have custom domain names, so you can obviously use your own domain name with an HTTP API. JWT authorizers. So if you're not familiar with this, this is a simple or simpler way to do authorization, secure way that allows you can use Cognito or Auth0 or some type of other service as an identity provider and then natively support that authorization with HTTP API. We also have the cores configuration that I just showed, as well as multiple stages with auto deploy options. And what that means is as I make changes to the stage in the console, the changes are going to be auto deployed. Now this is optional. You don't have to have it turned on, but it comes in really handy if you're working on a development or a staging environment that you're not worried about pushing it automatically, that you want it to go out every time you make a change. I'll tell you, I do a lot of speaking on HTTP or a lot of speaking on API Gateway in general. And one of my biggest issues is I will be live coding and I'll make a change and then I will go to the website and my changes are not apparent or they're not working. And I was like, oh no, what did I do wrong? And I finally remember I didn't deploy my changes. And in fact, even to the point where I will tell the audience starting, look, you may see me getting frustrated and wondering why something's wrong. All you got to do is yell, deploy the changes. And they do that. It's really funny, but they will do that. So deploy your changes, but you can also use auto deploy when needed. In beta, we also came out with CloudWatch metrics with optional detailed metrics. It's so critical to have metrics and to be able to get it detailed metrics if you need it. I encourage you, if you're running an API, follow the metrics. Pull them in, react on them, know what your API gateway is doing. And finally, access logging. And access logging is great because you can use this to see, who's hitting your API, where are they coming from. You can do a lot of analytics on your application through the access logging, even getting into something like Kinesis Analytics where you can do real-time data. All right, so let's climb into what the HTTP API feature set looks like at general availability, which was March 12th of this year. So we're going to go one by one on these. So the first one I'm going to talk about is one I'm very excited. I'm excited about all of them, but this is a highly requested feature, and this is private integrations. So what does this mean? When you're building architecture that's not serverless, when you're using something like EC2 instances or Elastic Container Services or Elastic Kubernetes Services, maybe databases, something like that, these need to reside in a VPC. Okay, your virtual private cloud. This is a layer of security. And as I've already mentioned earlier, anytime you have a layer of security, use it. Okay, and so what happens is to make these publicly available, up until now, you needed to use something like an NLB or an ALB, and those work great. But if you want to take advantage of some of the features that HTTP APIs offers, you can do that as well now. So what we've done is we've made this where you can set up private integrations via a network load balancer. And this is like the REST API. The REST API can do it via a network load balancer. However, we've gone further on this, and you can now do private integrations with HTTP APIs via an application load balancer. And this was highly requested from our customers because they may be running an Elastic Container Service or Kubernetes, and they already have the ALB set up. And they didn't want to convert over to an NLB because they're making use of the features that the ALB offers them. So what we did is we said, that's okay. We'll take and make it so that you can point HTTP APIs to your private resources via an application load balancer as well. But we took it one step further. And this is really cool. You can also do private integrations via AWS Cloud Map. If you're not familiar with AWS Cloud Map, let me talk through it just a little bit. It is a discovery service that allows you to register instances. Okay, so you start out, first of all, you're going to create a namespace. And in this, it's just any name I want. I created a GA service namespace with GA service NS. And all that is it's a logical name that I can group my services together for an application. So I may have an application that I'm demoing with, and I'll tie that up with a namespace. The next thing I'm going to create are services, and these are logical group of resources providing a specific service for the application. So for instance, I have a set of clusters, ECS clusters like we've been talking about. So finally, the service instances can be registered up under the service as well. Okay, so I have a namespace. Each namespace can have multiple services, and the services can have multiple instances. So what does that look like with the HTTP API? With the HTTP API, I'm going to create a private integration using AWS Cloud Map. And then I have 3 resources under a service, under a namespace. These are my 3, let's call this my 3 ECS clusters. 2 of them are version 2, and 1 is version 1. So if I just point at these, it's going to round robin to all 3 of them. So my customer might get some different versions of my resource. Now that may be what you're looking for. That may be, you may be saying, well, that's a multivariate test we're running and that's fine. So you could do it that way. But let's say I want to filter that down. Well, what I can do is the Cloud Map service attributes. So this is under the under Cloud Map, under the instances. They have custom attributes that come over automatically, and I can also add some. In this instance, I'm adding one called version. And for the version 2 cluster instances, I'm going to put version 2. For version 1, I'm going to do version 1. So what I can do is I can go back to AWS Cloud Map parameters under HTTP API. I can set that filter. So I could say I only want version 2. And what that looks like is now I only route, again via round robin, to version 2 instances, and version 1 is left out. So it's a great way to do some filtering. It's a great way to handle pulling in resources from a VPC via Cloud Map. Now, something that works across all 3 integrations, private integrations, is the private integration secure server name. And this is found under the advanced settings, under the integration. And I can set a secure server name if I have a certificate with that. So for instance, I'm going to use internal.mydomain.com, and I set that, and it has a certificate. So then HTTP API will use HTTPS to route to the service. If you don't set this, then it will use the default HTTP. So this is just, again, another layer of security. If you have it available, it works great. I'm going to show you how to build a private integration using HTTP APIs and AWS Cloud Map. Now, the first thing we need to know is what are we going to make public? Now, I've set up an Elastic Container Service, or ECS, cluster with 2 different services in it. I have service v1 and service v2. Each of these are running a different version of the website that I'm going to use as an example. I call it single digit. Now, if we go to Cloud Map, I also have a namespace that I'm calling the single digit website. Under the single digit website, I have a service called single digit backend. And this is all my backend resources. Under the single digit backend, I can go, and here are the 4 ECS instances that make up my cluster, and those are all available, and you can see they're healthy. And if you look under here, they have some custom attributes that we talked about. The specific one we're going to be looking at a little bit later is ECS service name, which is going to differentiate between single digit v1 and single digit v2. All right, so let's go to API Gateway. Now, in order to build a private integration, you have to have a VPC link. Now, you can share VPC links, so if you have one, you might be able to use it again, or you may need to create a new one. Let's see what that means. So I'm going to create a VPC link. Now, I can create one for HTTP APIs or REST APIs. If I have one already created, I could share them between the same type of APIs. So REST APIs can share VPC link, HTTP APIs can share VPC link, but they can't cross over. Since we're using HTTP APIs, we're going to choose VPC link for HTTP APIs. Now I'm going to name it something logical that makes sense. Since I'm doing a single digit website here, I'm going to choose the VPC. I only have one available, and the subnets I care about are going to be A and B for now. Finally, I have a security group. Now, the security group that I'm using only allows resources within the same security group to talk to each other. So I need to insert the VPC link into the security group so that it can talk to those resources. I'm not going to worry about any tags right now. I'm going to hit create. And you notice it'll come up status pending, and that'll actually become ready very shortly. Now that my VPC link is available, let's go ahead and build out the rest of the resources. The next thing we're going to do is build the API itself. Like I said before, we're going to use an HTTP API to do this. So I'm going to build this. Now, I can add an integration when I'm creating an HTTP API, but I can't add a private one. It'll tell you, you'll notice here, that you need to go ahead and build it and then add it after the fact. So we won't worry about that. We will, however, go ahead and name it. And I'm going to go next. I'm not going to worry about adding the route. We'll take care of that in a little bit. And then the default stage is fine with auto deploy turned on. And now I can do my overview and see everything is there. So let's go ahead and create that API. Next, we're going to add our integration. So we click on integrations. I'm going to go here to manage integrations. I'm going to choose create. Now I want a private resource. So I'm going to click private resource, and I'm choosing, I could do ALB or NLB, but I'm going to choose Cloud Map. Now with Cloud Map, I choose the previously configured namespace, which is single digit website, and then I tell it the service I want to use, which is single digit backend. I'm not going to worry about anything else at the moment, although I will show you here where you can see which invoke method we're going to pass. I'm going to pass any and everything. Here's that secure server name I talked about earlier, and any other data you want to pass. The last thing I have to do is set the VPC link we're going to use. So I use the one that's created and available, and I hit create. Okay, I now have a private integration that connects HTTP API to resources in my VPC link. So the next thing I need to do is I need to add some routes. So I'm going to go to routes. I'm going to choose create. And for now, I'm going to say anything on the route, but I can choose anything here. You can see that, but I'm going to say anything on the route, and I'm going to hit create. Now I'm going to click on that, and I'm going to attach the integration we built earlier. So I'm going to say, just choose the drop down here. You can see all the description of it, and I'll go ahead and attach that. And that's it. That builds a private integration. So let's see if it actually works. So if I go here, now probably it's not going to work first time, but let's take a look here. It worked first time. Look at that. I'm so excited. Tell your friends. So you can see I've got single digit version 2, and as I refresh this, I get version 1. So what do we need to do? Well, we're not doing a multivariate test here, so we need to change some things out. So let's go back to AWS Cloud Map, and let's get that parameter name I talked about earlier. We want it to be ECS service name. We want single digit V2 because we want the latest and greatest. So I'm going to go back to my integration, and I'm going to manage the integration here, and I'm going to edit that. And right under here, under AWS Cloud Map parameters, I'm going to paste that value. And I'm going to say should equal, and look at me, I've already forgot the name of the variable I'm going to use. So just to make sure, we'll call single digit V1. We'll copy that just to ensure I'm accurate. And we're going to say, there we go. So now when I save that, now let's try that. Okay, and I'm going to refresh this. Let's give it a few moments to kick in. There we go. Now we get version 2, and that's all we're going to get. I can refresh this over and over and over and over, and we're just going to get that. And that's how you build a private integration with HTTP APIs and AWS Cloud Map. All right. Let's jump into the next set of features. The first is custom domains. Now, like I said, we released custom domains on December 4th when HTTP APIs came out in beta. However, we made some changes when we brought it out in general availability, and here's how it works. Previously, if you had a custom domain, you could only point it at a single type of service. So, for example, if I have mydomain.com pointed at path or /path1 pointed at an endpoint under a REST API, all my other endpoints under that same domain had to point to the same type. So you couldn't share types of API. Now, however, you can do multiple types of API endpoints. So you have custom domain cross compatibility. So my same domain can point some of my endpoints to an HTTP REST API, and some can point to an HTTP API. And this is important because what you might be doing is you say, okay, as I'm building this, maybe just a little bit of my application, let's say 10% of my application needs the full feature set that's offered in REST APIs, but the 90% does not. Okay, so I'm able to save money by saying, okay, let's point the 10% at the REST APIs, get the feature set that we need, and then we'll come over and point the rest of them to HTTP API. And we'll talk more about that and what features are available in a little bit between the two. The next service we have is request throttling. So it's important to understand throttling when you run an API. A lot of times I've seen people just, hey, it's up and running, I don't care, I'm not going to worry about it. But throttling is an important part of maintaining the health of your API. Okay, so something to understand is, first of all APIs are throttled at 10,000 RPS and 5,000 burst per region per count by default. Now, you may be thinking, 10,000 RPS, 5,000 burst, what does that mean? Well, let me explain to you. 10,000 first is 10,000 requests per second. So what this is saying that a combined bucket of 10,000 requests is available to an entire region in an account, and all the APIs in that account share that bucket. Okay, so if I have a production, a staging, or whatever, different APIs in the same account, they share that bucket of 10,000 requests per second. And 5,000 bursts. Now, burst means how many requests can API Gateway handle at the exact same time, and that's within millisecond. So, for instance, if I have 5,000 requests that hit my API Gateway at the same exact time, the first millisecond of a second, it's going to handle all 5,000. But if 5,001 hit at that first millisecond, then that extra one is going to get a 429 response. It's going to get throttled out. Okay. However, I can handle another 5,000 throughout the rest of the second, which adds up to 10,000. So understanding burst is what hits at the exact same time, whereas the RPS is how much can it handle per second. Now, I want to clarify that these are both soft limits. If you think you need more for your application, talk to us, and it can be raised through an automated process. So that's important to know, but these are the standard settings. So let me show you what we've added. This 10,000 is already by default, so let me show you what we've changed as we've gone into general availability of HTTP APIs. The first thing we've added is a per stage throttling capability. So you're able to say, if I'm running multiple stages on the same API, I can then say, hey, the default should get most of the traffic because it's a production. So I'm going to say, I'm going to open that wide, maybe 8,000, and I'm going to settle my dev at 2,000. Now you can also leave your production. You can say the default should have access to all 10,000 in a bucket, but dev should have only 2,000 in a bucket. So don't think of it as trading out. I have to take away from prod to give dev some availability, or take away from default to give dev some availability. You can have the default access to 10,000 and the dev access to only 2,000. All right, so the next thing we've done is we've added the ability to do a per route throttling. Now, a route is a combination of path and methods. So a route would look like in this example, I'm saying the route get and the route post. And that's how REST APIs work. You have different methods like get, post, update, delete, and those are sent to the API. So what I can do is I built this URL shortener that I want to be able to take a lot of traffic. Okay, so what I did is I said, look, the most important part of the URL shortener is the application and the response to the clients getting the shortened URLs. The admin is secondary, and the admin is going to use things like post and update and different things like that. So I'm going to give access to my route get method. I'm going to let it access most of my traffic, whereas my post is going to be throttled down. Now, these are just some examples, showing how this works, but it's important to understand your application and to maintain throttling based on how your application should act. All right, so the next feature we're going to talk about is stage variables. With API Gateway, on the different versions of API that we offer, we have this idea called a stage. And a stage is different versions of the API. Okay, so I can say I have a dev stage, I have a production stage. In this example, my production is my default stage. And for each of those, I can create a stage variable. So each of these have an API key and Lambda. Now this API key that I'm using is not a secret. It's just simply saying which API to use. And the Lambda is just declaring which Lambda to use, and I'll explain that in a moment. I do not recommend this for secrets. Okay, if you're storing passwords here, not a good idea. If you're storing, highly secretive information here, not a good idea. We suggest best practice for that is to use that in the parameter store, or something like that. So again, I would encourage you, don't store secrets here, but these are great for just simple knowledge on which stage I'm on and some information for developing, things like that. Now, the first thing that happens with this is it is passed to the integration on the back end via the event. So you can see there'll be an entry in there. It'll show, hey, these are the data. Then what happens is the back end integration, the Lambda, for example, can use the data. It can say, okay, I need to use this API key. Okay. Now you may be wondering why I did a Lambda one. Well, the second way you can use a stage variable is in actually defining the integration itself. Okay, so stage variables can be used to dynamically configure integrations. So in this example, I'm giving an ARN to the Lambda that I want. But instead of actually naming the Lambda, I'm passing that variable called stagevariables.lambda. So when it makes the call, let's show you in an architecture, when I call the www.mydomain.com, and it's on the default route, it's going to pass the prod Lambda, and that'll be what's invoked. If I go to www.mydomain.com and I hit the dev, that's going to be the dev stage, and it'll invoke the dev Lambda. So you have control over which Lambda you want to invoke by using the stage variables. Now, if you decide to go this way, it's important to say, in the default settings, if I'm just going to use one Lambda, we're automatically going to grant API gateway permission to invoke your Lambda function. Okay, you see that's toggled on, that's by default. However, if you're using stage variables to declare your Lambda, then you need to use a custom setting, and this you need to turn off the grant API gateway permissions to invoke your Lambda function toggle, and you need to load your own role. And the reason for that is we don't know how many Lambdas you're going to be using, and so what we're doing is saying, hey, and we obviously don't want to say, hey, invoke any Lambda. We don't want to go, for permission reasons, we don't want to open that wide up. So what we want you to do is to go ahead and say, just put in the role and the different Lambdas that you're going to use, and those should be in the role, and you should have invocation rights in that role. So use the custom settings when you need that. The next feature we're going to talk about are the payload features. And in the payload features, we have a new event feature, or a new event format coming in. Now, right now, you're looking at Lambda event format 1, and you can see it's got a lot of data in here, and I've trimmed some of it out. We have a link and that I'll give you in a moment where you can see the full structure and comparison. But there's a lot of data passed through, and there's some redundancy. For instance, you can see where we have headers here on the left side and multi-value headers, and so they're kind of separated out. Now, what we've done is we've created a V2 that's much more concise, that shows how to put these all together. And the full comparison you can see here is at http://bit.ly/payloads. And that'll give you a link to the documents where you can see the full comparison of these. The second part of the payload change is in the response. This is how the Lambda can respond. Now, in version 1, and if you've used Lambda at all, this might look familiar. You can see that we have a status code, a body, and a header, right? Now in version 2, and this was the required format to come back to API Gateway. In version 2, you can just pass the body. Okay, so you can say, pass the body, and HTTP API will use logic based on the response you get back from Lambda and the core settings that you have to build a proper response for you. So you have a lot of flexibility on how you can pass that back. Now, it's important to understand that version 1 does not equal version 2, and you have to use the same for both incoming and outgoing. So the version of the payload must match for both incoming event and the return response. So if I choose version 2, which is by default with HTTP API now, then I can just pass back the body. If I use version 1, then my Lambda payload must have the status code, the body, and the headers. We've also obviously broadened our support region. Now anywhere that has API gateway will now have HTTP API. During the beta, it was limited, so we've opened that up. All right, so let's talk about choosing an API. And this is a question I get a lot on, all right, which one should I use? And I can go through and I can list different feature comparison, but really it comes down to several questions. The first is, does the application require WebSockets? If yes, then we should use the WebSockets API. If no, then you have to ask yourself, does HTTP APIs meet the feature requirements? If yes, then we choose HTTP API. If no, then we choose REST APIs. So the rule of thumb here is, if you're not using WebSockets, obviously WebSocket API is going to be what you want to use for WebSockets, but between REST or HTTP APIs, you want to use HTTP API if the features allow it. Okay, if we have the right features that you need. HTTPI, I mean, we've already talked about it. It's faster, it's lower cost, and it's better. It's going to save you money, it's going to have faster response time, and it's going to be easier to set up and use. However, if the features don't meet your requirements, then you can use REST API. But this is for now. So something about the future. So we said we're going to talk about the future. We plan to bring feature parity between REST APIs and HTTP APIs. So what you have is an equal balance between the two of them. So honestly, again, if HTTP APIs meet your needs, then that's the way to go. If it doesn't, then use REST APIs, but continue to monitor this because eventually it will meet your needs from a feature set. Now, you may be saying to me, well, okay, so I use REST APIs, but then I have to migrate. Well, we've thought about that. So we built some services to help with that. And mainly that's the Swagger OpenAPI integration. And how this works is if you take an export from your REST APIs, you export a Swagger or OpenAPI document, you can import that into HTTP APIs. And the cool thing is HTTP APIs will implement all supported features. If a feature is unsupported, it won't implement it, but it will let you know in the console. It'll say, hey, this is not currently supported. So when you're transferring over, you will have a heads up if one of the features that you're using on REST API is not supported on HTTP API at the moment. So migration should be hopefully fairly easy to move over, and of course, we're here to help. And that's the wrap up on the features coming out with HTTP API. I really appreciate you taking the time to listen and to learn about HTTP API. Again, my name is Eric Johnson. You can reach me at EDJGeek, and I'm glad to help in any way I can to get you started with this. There'll be more coming out. Watch for blogs, watch for videos, and you have a great day. Thank you.